Live, it's already live.
Okay, dear student, let's see what is there in this question. The radius of a sphere is capital R. The absolute uncertainty in R is delta R. What is the fractional uncertainty in the volume of the sphere? So it's a very typical question from the topic of propagation of errors in error and measurements. Although, this topic is not given in specifically in our new syllabus, by the way, but of course there are details. Of course, we have to do this topic, and this is one of a very important topic for the paper 1B. So let me tell you how are we going to do these kind of questions. Let me tell you how do we approach it. So first of all, we are going to concentrate on a formula which relates the volume and the radius of the sphere, and what that will be. So the volume will be given by 4 by 3 pi r cube. Now this, I remember the formula, and if you do not remember it, I probably believe that it is given in the data booklet. You can please make sure, and you can start from this. Okay, now what we do, we just like v is directly proportional to r cube. Now that is the only piece of information which is important for us. So the constants can be left behind. It is v and r cube. From there, if you want to find the percentage error or the fractional uncertainty in volume, that will be equal to 3 will come in front, and then you have to write the uncertainty for r. This is how you do it. This is the name of the topic is propagation of errors, and what I'm doing is the exponent kind of thing. There are like multiplication, then division, then exponent, three cases under the case of the propagation of errors. So this is the method that we do. Delta v by v is equal to 3 into this. Now 3 times delta r by r. So it's just delta r divided by r. Yeah, that's it. So A is the correct answer. That's it. We are not going for B, C, and D. There are some students, those who would be going with D or those who would be going with B, because there is cube there. So they usually think that when the radius is cubed, then the error should also be cubed. That's completely wrong. I don't know from where this information is coming, but that is completely wrong. If it is having 3 power, then 3 will be multiplied to the uncertainty. Okay, so A is the correct answer. So this is how we do it. Thanks for watching this video. Please continue watching, and all of the other questions are coming up in the list. Okay, dear students, all the best. Bye. Okay, so question number 2. Astronomers have measured that the magnetic field of some stars are of the order of 10 raised to power 10 Tesla. The physicists have
Done होगा
measured the
हमारा है.
magnetic fields of some laboratory magnets to be 1 Tesla. So there are two measurements that they are making. So one is
ठीक
for
है.
the astronomical body, which is completely huge, like 10
जय
raised to
श्री
power
राम.
10 Tesla, and another is just one magnet, which is in the laboratory. The magnetic field is, of course, very low, which is 1 Tesla. So you are making the measurement of this order, like you're using the same instrument, but there is 1 Tesla here and 10 raised to power 10 Tesla for the astronomical body. Three types of uncertainties are given: absolute uncertainty, fractional, and percentage. What type should the group use to compare the precision of their measurement? Now, couple of things that you have to understand here. Now, first of all, you must know what is the difference between these three types of uncertainties. So let me explain you that. Let's say you are measuring a length of a road or something, and it comes out to be 10 meters, and you are creating an error of 1 meter for every 10 meter. And then there is another length, you can call it length 2. So that length is very big, a kind of 100 meter, but still the error remains 1 meter. Now, absolute uncertainty is plus minus 1 in both of the cases. This factor is called the absolute uncertainty. So clearly the absolute uncertainty is the same for both of these measurements. Clear? But clearly we can say that this measurement is far better than this measurement. Why? Because this is the error of 1 meters for the length of 10 meters, and this is 1 meter for the length of 100 meters, which becomes a genuine case. So that's not a problem, I would say. So absolute uncertainty is not doing justice for these two things, isn't it? So we have to create another types of uncertainty, which is fractional uncertainty. Now, the fractional uncertainty is when you take the fraction here. So this is 1 by 10. It becomes zero point 0.1 in one case, and in another case, it is becoming 0.01. So clearly, this is showing you the precision of your instrument, that even for 100 meters, what is the error that you are going to make. So this is the precision of your measurement. And what is the percentage uncertainty? When you multiply the fractional uncertainty, that is delta L by L, this is fractional uncertainty, you multiply it with 100, becomes the percentage uncertainty. So the percentage uncertainty here will be kind of like 10%, no, 1%. You're multiplying with 100, yeah, 10%. And here you multiply, it comes out to be 1%. So you can see that the percentage error in this calculation, in the first measurement, is whoopingly 10%. That is too high. And the measurement in the L2 is coming out to be 1%, which is fairly good. It means that both of these can be used to find the precision of the measurement. Well, these topics are very important for paper 1B, and I tell you, for your IAs. If you are writing the IAs, you have to consider these things when you're making some measurements. You have to find the errors. So this is what is propagation of error. Like, you have to fill your IA with this kind of information. Then your IA becomes stronger. Clear? So it's very important for us to understand what is happening here. So the answer will be 2 and 3. So 1 is wrong. So C will be the correct answer for this question. And this is how we do this question. Okay, dear students, thanks for watching. This is Professor Varun. See you in the next video. Bye. Okay, dear students, let's see what is there in this question. A runner accelerates from rest, reaches a constant speed at time t. So first of all, this person was at rest, and it starts its acceleration, which is a. And of course, after some time t, it will be gaining some velocity because v is equal to u plus at. So acceleration is there. So definitely velocity is increasing. There is no doubt. And after that, after reaching certain velocity, after that the acceleration becomes zero immediately. There is no gradual decrease in acceleration or gradual increase in acceleration. Nothing happened like that. It is immediate decrease in acceleration. Like earlier it was accelerating, but now the acceleration is zero here. So now the acceleration is zero and it is moving with the constant velocity now. So what will be the graph? So you might have done these graphs here. If you have not done it, I think my lectures are also freely available for the topic kinematics A1 on the YouTube channel. You can watch those videos and you can see those graphs there. So I have given that information there, that if the velocity is like, if the acceleration graph is like this with respect to time, then the velocity graph is is a straight line. No, sorry. If the acceleration time graph is constant, like acceleration is constant here, not the velocity, sorry. So in the first case, the acceleration is constant. The velocity will be a straight line if the acceleration is constant. And the displacement graph will be a parabolic graph. So this we have already discussed. I would be creating a link in the like after this video, and you can go and watch that video. So this graph here is parabolic. It means that first of all, it should be this kind of a graph. Why? Because acceleration is positive, and this graph is happening only in the C and in the D. But B is wrong and A is wrong. So either the answer is C or the answer is D. Now, after that, the velocity becomes constant, reaches a constant speed. Constant speed velocity means that the displacement is increasing. I have drawn the other graphs also there, that if the velocity is horizontal, like the velocity is constant, then the displacement time graph will be a straight line like this. So this all graphs and all information is there in that video. Okay, so this is a straight line here. So first of all, the displacement is like this. After that, the displacement becomes like this. These are the two variations. So clearly D is at a steady vertical velocity of 10 meter per second. An object is released at rest relative to the balloon when the object is at the height of 120 meter above the ground. So the picture is something like this, like that. Let's say this is the balloon and there is a stone which is placed on it. Now the balloon is going up. So when it reaches a height of 120 meters, here is the balloon now. So at this moment, this point has attained a certain velocity, isn't it? So okay, it was moving with a constant velocity, so it is 10 meter per second, and it drops. So it is going down. So it gives you a feel that might be that it is going down like this, but it is not going down like that. As soon as it loses the contact with the balloon, we can forget the balloon and we just consider the stone here. Now what is happening? Like this body, the object, it has jumped out of the balloon from the balloon with the speed of 10 meter per second in the upward direction. So actually the trajectory of the stone will be like this, going a bit up and then falling down on the ground. That is what is happening in this picture. So this body is going upwards with the speed of 10 meter per second, and then it reaches at the highest position and then go back and reach to the ground once again. So this is the picture which is happening. So this topic is not a new topic. Again, this is from kinematics, and all those lectures are free for you to watch. If there is any problem, you can watch those lectures. So what is happening is like it is going like this, and then we are going to apply the Suvat equations now. So I would be applying what time to the nearest second does the object hits the ground. So you acceleration will be taken as negative 10 because acceleration will be in the negative direction, and it is not given here what value you want to have. So let us take 10, and this is t square. Now what is s? S is the displacement that will be happening. So this point from where the motion starts is chosen as the reference point or the origin. So from this, we're going to find the final displacement. So the final displacement is anyways in the downward direction like this. And so the downward, and it is given as 120 meters. So this is 120 meter in the downward direction. Try to understand. First of all, in these kind of cases, we will create the sign convention. After creating the sign convention, we will go for finding what are the values that we are going to substitute. Now when it comes to displacement and like anything, we just choose this point as the origin and we think from that point of view. Now if you compare the initial position and the final position, we don't care about this position, like how high is the body going. We don't care about what is happening during the motion. We only care about the initial and the final position. The distance is 120 meters, that even in downward direction. So this will be negative 120. There you are. We have created this equation. This is 5 that goes to the other side. 5t square minus 10t minus 120 is equal to 0. Still not simplified, so I can divide the whole equation by 5. So it will be t square minus 2t minus 5 2s are 10, 5 4s are 20, 24. Yes, this is the equation that we have to solve. So 2, 24, 6 4s are 24. So t square minus 6t. So t minus 6. 6 will be the answer. So t minus 6 can be taken, like t can be taken common here, and 4 will be taken common here. So you would be having, mathematically speaking, two solutions, two roots, but these two roots are like, they are not the right answer. So the time cannot have a negative value, so this will be neglected. Only 6 will be the correct answer. So this is how we do this question. The multiple ways, multiple points at which you can make a mistake here, but it is very crucial for you to understand the concept. How are you doing the thing? And once you do it, try to find these kind of questions more. There's so many questions of the same thing. Try to do them by yourself. Okay, dear students, all the best. Bye. Okay, dear student, let's see what is there in this question. When a horizontal spring is extended by a distance x, the force acting on the spring is F. The extension of the spring is directly proportional to the force that we already know. What is the energy stored in the spring? So you have to find what is the energy stored in the spring. So although it's a very typical question which is usually addressed in our theory classes, and we find it that the potential energy of the spring is given by half kx square, but we are not using this formula here, isn't it? Like, because they want you to find the potential energy in the terms of F. How can we do that? So, okay, we would be using the same formula. F is equal to kx, because it is explicitly written here that the force is directly, the extension is directly equal to the force. So clearly it is following the Hooke's law. So F is equal to kx is also known to me, and potential is equal to half kx square. So I just want to substitute this value here somehow. So how can I do it? So the potential energy can be written as half, and I think I should be multiplying k in the numerator and in the denominator, like this. So kx is the force, and I can substitute the force here. So it becomes 1 by 2 f square by k. So thereby f square by 2k will be the answer. Uh, okay, they might be, they are substituting further, I think. Let me see if it is correct. Yeah, it is, the calculation is absolutely correct, but the answer is not matching, so they might have substituted something else. So you can clearly see that in these equations, the answers here, k is not there, but we have created k, and we have eliminated x, but for them x is there. So that is the mistake that we did. Now let us try back again to convert k in the terms of f and x. So k will be equal to f by x, or we can directly substitute that. One moment, please, one moment. Unnecessarily, I don't want to create a very big equation, and you would be feeling like, why is the teacher doing like that? So the potential energy is equal to half, and k will be written as f by x into x square. So clearly fx by 2 is the correct answer. Clear? So this is how we do it. So either way you can do it. Like, the other way was also not wrong, but that was giving you the answer in the terms of k, but you want to eliminate k. This happens many a times in the questions, but the biggest hint is, what are the variables which are being used in your options? It gives you a hint that you have to eliminate k and bring back x. So there was something problem. So don't feel that you are doing something wrong and your answer is not matching to this answer, and at that time you feel like, what the hell, and you just throw your composure. No, that is not to be done. Just take the clue from these kind of questions. Okay, okay, dear students, this is Professor One. Thanks for watching this video. Move to the next. All the best. Bye. Okay, dear student, let's see what is there in this question. A toy car collides with an identical toy car at rest. The cars stick together. It means this is an inelastic collision. The surface is frictionless. Three statements about these collisions are: the speed of one car decreases and the speed of the other car increases. Well, of course, there are two cars. One car is moving with with some velocity. The other is at rest. So when they stick together, they start moving constantly with a constant speed. So of course, for one car the speed will reduce, and for the other car the speed, it was already zero, so it will increase. So point number one is absolutely correct. Total momentum is conserved, absolutely correct. Whatever be the collision, you don't even need to think about it, whether they are sticking together, whether they're not sticking together. Whatever is happening, if the cars are sticking together, the momentum is always conserved. If they're not sticking together, even then the momentum is always conserved. So momentum is always conserved, no thinking involved. Kinetic energy is conserved, never. Kinetic energy is not conserved here. This is a perfectly inelastic collision. In fact, after the collision, when two bodies stick together and they start moving together, the loss of kinetic energy is maximum. So, kinetic energy is conserved? No, but the loss of kinetic energy, it becomes maximum in this part, in that particular case. Okay, so which statements are true? One and two. So A will be the correct answer. Point number one that you have to note here is that the momentum is always conserved in whatever type of collision you're talking about. So there is no thinking involved. If the collision has happened, momentum is conserved. Kinetic energy is conserved only and only in elastic collision. Okay, students, thanks for watching. All the best. Bye. Okay, dear student, let's see what is there in this question. A trolley of mass m is moving with the speed u. So the mass of the trolley is given as small m. A load is dropped onto the trolley. So the load is dropped onto the trolley. So it is coming from the top. So it is 90-degree angle, so that it immediately attaches to the trolley. So again, the both of the bodies, they're now going to stick together, and so they're moving with the same velocity. The speed of the trolley and the load becomes v. So this is v. Earlier it was moving with u. What is the mass of the load? So we have to find the mass of the load. Let us take it as capital M, because this is small m. So by applying the conservation of linear momentum, and we would be considering only the x-axis. So when this load was moving with the some velocity, we don't care about that. It just sits on the trolley, and after that it starts moving with the velocity v in the x-axis. So what is the initial momentum? The initial momentum will be m into u, and this will be equal to the final momentum of the complete system. So now what is the final momentum? It is capital M plus small m, like the total mass here is moving with the velocity v. So that is the total momentum after the collision. Both of them should be equal to each other, because the principle is conservation of linear momentum. So we just compare it, and we are going to find the value of capital M. It can be taken as m into v plus m into v. This is m into u. Small m can be taken common. It will be u minus v divided by v will be equal to capital M. Yes, this will be the correct answer, and so clearly A is the right option here. I think arithmetic is not that very difficult here. You can just see it. Okay then, dear students, this is how we do this question. All the best. Bye. See you in the next video. Okay, dear student, let's see what is there in this question. An object of mass m is being heated by a source of constant power P. The rate of change of temperature of the object is S. What is the specific heat capacity of the object? Okay, that's a very good question, I would say. The object M is being heated. So, of course, we would be using the formula Q is equal to MC delta T. Now, that becomes like you can write delta Q. So, this is the most basic formula that we are going to use. Now, when they're talking about specific heat capacity and they're talking about a mass getting heated up, you're talking about the heat which is transferred to the body. This is the formula that we have to use. But there is a catch. Up to this, everybody know. But here they're talking about rate of the change of temperature of the object. So they are talking about the rate. So there are two words, by the way, never confuse them. One is rate, another is gradient. So whenever you say rate, rate is when you divide something by time. So it says the rate of change of temperature. So he's talking about this divided by delta T, which is small t. Small t is time, capital T is temperature. So if you are dividing the right hand side with delta T, you have to divide the left hand side also with delta T. So your equation has changed. Now it is no longer Q is equal to MC delta T. It becomes the rate of heat flow into the body, and it is related with the rate of change of temperature. So it's completely a new formula now. So this delta T by delta T is given as S. So I can, and this delta Q by delta T is actually the power. So I create another formula. Power is equal to MCS. What is the specific heat capacity? This is C. So C is clearly equal to P by MS. And D will be the correct answer. This was a very good question, I would say. Kudos to IB, because I've never seen this kind of question earlier in IB. So you're dividing this by time, and at that time it becomes heat transfer question rather than simple Q is equal to MC delta T. Okay, dear students, so this is Professor Varun. Thanks for watching. All the best. Bye. Okay, dear student, let's see what is there in this question. An ideal gas is in container with a movable piston. The piston compresses the gas rapidly. Now, this word is very important. Like you can compress the gas, but here the gas is compressed rapidly, like this. The temperature of the gas increases. Why? The molecules bounce off. Of course, the temperature of the gas will increase. PV is equal to nRT, and like you know what is happening in adiabatic process, what is happening in other processes. So of course, when such a kind of thing happens, it usually acts like adiabatic process, by the way. So the temperature will be increasing there. Now the question is, from the micro level, from the molecular level, why the temperature is rising when you are doing that. So the molecules bounce off the piston with increased speed. So now the molecules are having bigger speed and they're heating. Well, that should be the correct answer probably. I would be reading other options also. Why? Because temperature is only and only related with the kinetic energy of the molecule, that is the speed at which the molecules are moving. So if you say that temperature is increasing, clearly the speed is increasing and the kinetic energy is increasing, no doubt about it. So A should be the right answer. But let us go for B, C, and D and try to understand why are they wrong. B, the molecules collide with piston more frequently. Well, technically speaking, yes, even this is right, that the molecules, they will be colliding more frequently. Why? Because now they are occupying the lesser space, so of course they will be colliding more frequently. But is that the reason for increasing the temperature? I don't believe so. Might be in pressure, we can assume, but even in the pressure, no. Because from the theory, the ideal gas theory, what we have is 1 by 3 rho v square. That is the formula for the pressure. And you can see that there is nothing there for frequency or like the time of the collision or something, that is not required here. So this thing is not happening. So pressure is also not connected with the frequency anytime. So B is not the right answer. Now going for the C. Molecules exert a greater force on piston. Molecules exert a greater force. Well, that is actually the right thing. Why? Because they are moving with more speed, and because of the more speed there is more momentum, and the collision is taking place and there is a change in momentum, of course there is more force. Molecules exert a greater force on piston. I can only say that given this condition that the ideal gas is in a container with a movable piston, the piston compresses the gas rapidly. So you are actually talking about a certain context. So even this is not wrong. The pressure will be more. There is no doubt about it. The pressure is going to increase. So if the pressure is increasing, it means that the force has increased. So these are very near kind of options, I would say. So molecules exert a greater force, but it's not about the force, like it's actually about the collisions which are taking place at the higher speed that increases temperature. So this is, practically speaking, this is right, this is also right, but they are not related with the temperature. The number of molecules per cubic meter has increased. Now, even this is correct, isn't it? Because the volume has reduced, and so of course the density is higher. So there are more number of molecules per cubic meter. That information is correct. But again, it has nothing to do with the context mentioned here, nothing to do with the temperature. That is why D is also wrong. So this is one such a question, I would say, that all the options, they are all correct, and still you have to choose the best out of these four. So it's no more this is correct and other threes are wrong. It is this one is best and other threes, they are right, but they are not the best. Okay, dear students, this is Professor Varun. I hope you like the video. Please like and subscribe to the YouTube channel and watch the next video. All the best. Bye. Okay, dear student, let's see what is there in this question. A traveling wave of time period 2 seconds is moving through a medium. So the time period is given and it is moving through a medium and it is a traveling wave. So it's just traveling, okay, from left to right, let's say. The graph shows for one instant the variation with the distance. Variation with the distance. Okay, on the on the x-axis you have distance, which is in meters, and on the y-axis you have displacement of the particle, which is again in meters of the medium. Yeah, so I told you, and if you have not watched the lectures, by the way, the lectures for C1 are absolutely free to watch on this YouTube channel. The link will be provided at the end of the video. You can just go there and watch all the videos, okay, and the things will be very clear. Now this is about the traveling waves. Okay, it's not simple harmonic motion. There are two different graphs. Now, one graph is having the displacement here and the time. And the another graph is when you have displacement versus distance. Now, this is displacement. So, meter on the y-axis and meter on the x-axis. When you have time on the x-axis, like of course you have the same kind of a graph for both of them, like sinusoidal motion. So students usually get confused, like what the hell, what is the difference? Because in this case, let's say meter is given and you don't know what is the difference in these two graphs, isn't it? Yeah. Now, displacement and time. This graph is used when you are talking about simple harmonic motion of just one particle. But this is literally a traveling wave which consists of many particles. Which consists of many particles. So every point is a different particle. Now, this particle is undergoing a simple harmonic motion here at this location. So it is at one of the extreme. Now, this is its mean position. This will be the extreme position. So after some time, the particle is going to go to up and then coming back to the mean position, going to the extreme position again. So it keeps on moving up and down at the same location. So this particle P is never going to have the motion along the x-axis. It's not going towards the x-axis. It is just going up and down. So all the particles, you can take this particle for that sake, this particle for that sake, they all are different particles, first of all. So when they say that this is on the x-axis, it is meter, this is the first thing that comes to my mind, that we are not talking about simple harmonic motion. We are literally talking about the wave, and the distance between the two crests will be equal to the wavelength. Distance between the two trough will be equal to the wavelength, like that. These things automatically crop up, okay? That is what should be happening with you. Now, what is the speed of the wave? So you want to find the speed here. Okay, so let us see what is the distance traveled by the wave. We're not talking about the particle. There are two velocities now. This is the wave velocity. And when the particle is going up and down, it will be moving with a velocity which is written as Vp, the velocity of the particle, which of course changes, which is variable. The direction is also changing, the magnitude is also changing. As per the wave is concerned, the velocity is completely constant. So there's no problem. So we can just apply distance is equal to speed into time. So it is covering a certain distance. Let us see. Let us say it's going from, like, the time period is given as 2. So we are going to find the wavelength. So the wavelength, as I told you, is the distance between these two crests. So the wavelength will be 1.5 meter. So the velocity of wave will be lambda by t, which is 2. So this becomes kind of like 3 by 4, so 0.75 meter per second is the velocity of the wave. Do you get it? So this is actually equal to v is equal to f lambda. Like, we can use the same formula. This formula is valid on wave, and we are indeed talking about the wave. So if you would be using the formula v is equal to f lambda, there will be no problem here. Lambda by t, this is what we have done. F is equal to 1 by t, no problem at all. Why? Because they are not talking about the particles undergoing simple harmonic motion. If they are talk about the particle, these formulas are not valid. Be very careful. Okay, at that time we would be finding the total distance traveled by the particle divided by the total time. That will give you the average velocity. But anyways, they are not asking that. Okay, so the answer is 0.75. Yes, so A will be the correct answer for this question. So this is how we do it. Okay, dear students, thanks for watching this video. The link for the topic C1, that is simple harmonic motion, is given here. You can watch those lectures. They are free. All the best. Bye. Okay, dear student, let's see how to do this question. Source X and source Y both emit waves of the wavelength 0.4 meter. There is a constant phase difference of pi between the sources. Okay, there have never been this kind of a question earlier in IB physics. So this is first time I'm doing this kind of a question for IB. Okay, so this is going to be different. Be very careful. The point P is 5.2 meters from X and 4.6 meter from Y. The amplitude of each wave is A when it reaches P. So the amplitude here is A and A. What is the amplitude of the resultant wave at P? Okay, dear students, so listen to me. Till today, till now, what we did in the case of interference, we always have taken the phase difference to be 0 when they initially started at the point X and at the point Y. So the phase difference was 0 earlier. Now, what do you mean by that? It means that when the wave is starting with y, let's say it starts with the crest and the trough. Now, if the phase difference is zero, even at x, they are starting with the crest and the trough. So this was the usual case which was happening till today. But now onwards, that is not the case. Now it is given that the phase difference is pi. It means that for x, when the wave is starting, it is first a trough and then a crest. Be very careful. This kind of thing is not given in the books. This thing is not given anywhere. And IB has just given you a surprise with this question, okay? Even like I have never done this kind of a question in IB physics first. So this is what is happening. Now let me explain you what a coherent source is, and can these two waves which are having a phase difference of pi instead of zero, can they undergo interference or not? So there is a topic of coherent sources, and IB does ask question on coherent sources in paper 2 and others. So please listen to this. Two sources which are having the same wavelength or which are having the same frequency, only those sources can create interference. There are some conditions that have to be fulfilled, otherwise interference will not happen. So the first condition is that the two waves which are interfering, they should be the same wave, they should have same frequency, same wavelength. So that is condition is satisfied here, because the source x and y both are emitting the wavelength with 0.4 meter wavelength. So that is done. But there is another condition, that is on the phase difference. Now the phase difference should be constant. Now that is the condition. The condition is not that it should be zero, that it should be this value particularly, but it should be constant. It should not be variable, like now it is zero, now it is pi, now it is pi by 2. No, not like that. So in this question they have written pi, so that is perfectly clear, no problem with it, but it should be a constant value. So it is a constant value, that is pi. Now, so these are coherent sources, interference will take place. Now let us move to the question back again. So when I see these options, first of all, I can clearly cut B and cut C. Why? Because in IB physics, in your syllabus, there are only two cases which are taught to you. One is constructive interference, another is destructive interference. If tomorrow they tell you that there is another formula here, like that is not covered in your syllabus, I can give you that formula. But if that is not covered in your syllabus, these answers are not possible. So for this time, B and C are wrong. They are not the answer. I can give you the formula here, by the way. The resultant amplitude will be given by this, if ever you need this, and this is cos phi. The phase difference, the initial phase difference, for example, in this case it was pi, so we will be substituting this value pi here, and you can find the resultant amplitude at this point, but that is not in your syllabus. Be very careful. Now, so let us imagine that B and C are not in your options, so only A and only D is there. So either there will be destructive interference or there will be the constructive interference. So we have to find the condition whether constructive interference will happen or the destructive interference will happen. Now, usually we use this formula for the constructive interference, that delta x is equal to n lambda. This is the formula for constructive interference, very usual. But in this formula, there is one condition. Both of the waves should be starting with zero phase difference, which is not the condition in this. So how can I do that? So because of the initial phase differences, there is already a path difference. Now, I'm going to the second part of the video. Be with me. Now the initial phase difference is given. So okay, one path difference can be found, like 5.2 minus 4.6 is one path difference. So it is 5.2 minus 4.6, plus there will be additional path difference that has to be added into this equation because of the initial phase difference. Now what that will be? So that will be, you can say, I'm using this formula, delta x is equal to, or delta phi is equal to 2 pi by lambda into delta x. I've given you this formula many times now. So we would be finding delta x because of this. So delta lambda divided by 2 pi into delta phi. So the phase difference is given as pi. I substitute this value. So this pi and this pi gets cancelled out. It is coming out to be lambda by 2. So lambda by 2 is there. So I have to substitute lambda by 2 here. and then it will be equal to n lambda. So this becomes the condition for the constructive interference to happen. Now, overall, if you think this lambda by 2 can go to the other side, it will become n minus half, which actually corresponds to the destructive interference condition. So, in this particular case, the destructive condition will become constructive and constructive will become destructive. Why? Because we are having a phase difference of pi. That is why they have shifted. So both of them, they are swapped. But I don't want to confuse you, so we are not going into that. So you can just understand this thing. In IB, I don't believe that you would be getting a path difference which is different from either 0 or pi by or lambda by 2. It cannot be other, like lambda by 3. I believe IB will not be doing that. But nobody knows it. So we move with this. So 5.2 minus 4.6 plus lambda is 0.4 divided by 2, it becomes 0.2, which is equal to n into lambda. Lambda is again 0.4. So we want n to be the integer. If n is an integer, it will be constructive interference, otherwise it will not. Let us solve this condition. 5.2 minus 4.6, it becomes for 0.6 plus 0.2. So this is coming out to be 0.8, and which is equal to 0.4 times n. So clearly the n value is coming out to be equal to 2. So n value is 2, which is an integer. And like it could be any integer, 1, 2, 3, 4, doesn't matter, but it should be an integer. If it is an integer, constructive interference is taking place, and so the answer will be 2a. So first of all, I found the total path difference between the two waves, and I equated it with n lambda, simple, and I found it to be 2a. Now this is really a long process, but this is exact process that you should be actually doing. But provided it is IB and we are not going into that much of the details. So if ever the phase difference of pi exists, you can even create a shortcut here that the destructive interference condition will become will be used for constructive, and constructive condition will be used for destructive condition. Is that clear? Um, I can even do that. This is a very different question, so let me please do it and just see it. Let us try. So for the destructive interference, usually we take delta x is equal to n plus half lambda in IB, but it could be n minus half also. That is not a problem. So let us see if n is coming an integer here or not. So n, so delta x will be 5.2 minus this, which is 0.6. N plus half, and lambda is 0.4, so that can go to this side. Decimal gets cancelled out. It is 3 by 2. So you are subtracting half from 3 by 2. 1.5 minus 0.5, so n is coming out to be 1. This is an integer. Now you might be confused that what the hell is happening. See, this destructive interference is not including the phase difference of pi in its calculation. So this is valid and n is coming out to be equal to 1. But there is a phase difference of pi. So this formula, which is for the destructive interference, is no longer for destructive. It is now for constructive. This is what I was telling you. So this is the right method. Please watch the video again and again, couple of times, like 4 or 5 times to understand this, because this is the topic of interference C3. This topic is included in SL also in the new syllabus. So don't feel that this is difficult and it is not in your syllabus. It is in syllabus of every student who is watching this. So keep watching this video a couple of times and then you will understand each and everything. Okay, dear students, so all the best. Thanks for watching. Bye. By the way, all the lectures for the topic C1 to C5, they're already uploaded on the YouTube channel, but you have to become the member to watch the lectures for the topic C3. You can help yourself. All the best. Bye. Okay, people, let's see what is there in this question. An electromagnetic wave travels from the medium 1 to medium 2. The wavelength of the wave in the medium 1 is lambda 1. The wavelength of the wave in the medium 2 is lambda 2. the refractive index of the medium 1 is n, what will be the refractive index for the medium 2? Okay, and the wavelength is given. So wavelength in the second medium is smaller and the wavelength in first medium is bigger, which clearly means that this medium is denser. This is denser, this is rare. We would be talking about the Snell's law, that is clear. But we need not to talk about the incidence angle theta 1, theta 2. What is Snell's law? N1 sine theta 1 is equal to N2 sine theta 2. This is how I remember. It's quite easy to remember like that. So we are not concerned with thetas here. So we are not using Snell's law directly. We are going for the refractive index instead. So you can go for like N1 by N2. We are just finding the ratio here. And the refractive index is defined as the speed of light in air divided by the speed of light in that particular medium. Let's say this is a rarer medium is not air because the refractive index is N, not 1. So N1 can be written as C divided by V1 and N2 can be written as C divided by V2, and then the reciprocal of the denominator can be multiplied with the numerator, just a simple tool in arithmetic, isn't it? So it will become V2 by C, C and C gets cancelled out, so the formula will become V2 by V1. Now N1 is known to me, N2 is not known to me, and V2, okay, we have to know the wavelength. Okay, just a moment. V1. So this is how I have substituted the value of refractive index here. But we do not have the velocities, we have the wavelength. So we would be using the formula V is equal to F lambda. So the frequency never changes. So F lambda 2 divided by F lambda 1. Frequency and frequency gets cancelled out. Again, we have just extended our equation now. So lambda 2 is given, lambda 1 is given, n is given. You want to find the n2. So this n will go here. Completely like the rearrangements of this. So n goes to lambda 1. So n times lambda 1 divided by lambda 2. Okay, students might be getting confused here. One moment. So n2 by n, I'm just taking the reciprocal of that. So n2 becomes lambda 1 lambda 2 into n. So it becomes a. Hence, a is the correct answer, and this is how we do this question. Okay, dear students, all the best. Bye. Okay, dear student, let's see what is there in this question. A single pulse travels towards the free end of a hanging vertical string. The pulse is reflected. What is the shape of the reflected pulse? So what is actually happening here? We can see this is the rigid support, and from this rigid support the pulse is moving downwards. So this is going downwards, and this is the free end, and at this free end it is getting reflected. So you have to find like how is that going to be reflected. So what are the principles that we are using when we are doing questions for the reflection of wave? This topic is from the topic C3, so you can go into details if you want to refer to that. Okay, so what is happening here is, let's say there is this rigid support here, and there is this string, and there is a pulse which is moving towards right hand side direction. Of course it is going to cover this distance. It is moving at certain velocity. It will hit the rigid support and it will be getting reflected back. There is no doubt about it. But when it is getting reflected from the rigid surface, so what happens is it moves like this. So one thing that you have to note, that you can note here, is that definitely the motion of energy transfer is completely converted. It is completely opposite. It was going towards right, now it is definitely going towards left. But one more thing, it is getting inverted. Now it is getting inverted. Why? Because it is hitting a rigid support. It is hitting a rigid support, and that is why it is getting inverted. Now in the layman term we can say that it is getting inverted, but from the physics point of view we call it a phase shift of pi. So we will say that yes, it is getting reflected now, but there is a phase shift of pi which has taken place, and so the wave is now inverted and going back. What happens if this is a free end? Now what do you mean by free end? Free end is having a ring, and this is kind of a rod or something, or a pole we can say, and so this this ring here is not restricted. It can go up and down, it can move up and down like this, so it can go do anything there. Let's say the wave is coming towards the right hand side direction. Now what happens? Of course there is no way in which it can keep on moving in the same direction, because as soon as it hits this end, it has to be reflected. But because it is the free end, the inversion does not happen. The phase shift is not taking place. It means that it will be reflected just like this. So only the direction of the velocity will change, but the phase change will not take place. So these are usual principles that we take care for. Now in this question, you are in fact using a third principle. Now what is that? Now the pulse is not looking symmetrical. So the pulse is coming here and it is getting reflected from free end. So one thing is pretty clear, that because it is getting reflected from free end, it is not getting inverted. So the wave is definitely going to remain this side but not on this side. So this is wrong. It is not going this side. So out of this two options, let's see, like A, B and C, D. So these are the options. So in these two cases, the pulse is now inverted. And so definitely C is wrong and D is wrong. There is nothing that we can do about it. Now moving about A and B. Now what happens here? So you have to consider this. When the pulse is moving like this end is taken to be the front end, and this can be taken as the trailing end. So when it is going the other way around, even then the front will be front and the trailing end will be the trailing end. And that is the only case in the option B. Like for example, this is still the front and this is still the trailing line. So B is the correct option for this question and A is still wrong. So this is how we do this question. I believe this question is clear. This is a very important question. IB has asked so many these kind of questions also earlier. So you can remember this. Okay, dear students, thanks for watching the video. Please keep watching the other videos in the line. All the best. Bye.
फैमिली ਦਾ ਬਣਾਇਆ ਸੀਗਾ ਉਹ ਡਾਕੂਮੈਂਟ ਬਣਾ ਕੇ ਪ੍ਰਿੰਟ ਕਰੋ
Okay, dear student, let's go for this now. The electric field lines can cross each other. They are parallel to equipotential surfaces. They are directed from negative to positive. Show field strength by their density. Okay. So first of all, we must understand what is the electric field lines, what are the gravitational field lines. People, I think, not the electric field line, but the gravitational field line. Like we are doing the same topic in the topic D1 also, which is freely available as lectures on the YouTube channel. So the link will be there at the end of the video. You people can check out those lectures. Like the complete playlist for D1 will be there. Okay, you can check it out. So the characteristics of the gravitational field lines, they're absolutely same as the electric field lines. Even the gravitational equipotential surfaces and the electric equipotential surfaces almost same. Of course there are a couple of differences, but you can understand the majority of the things. Okay, now the electric field lines. So electric field lines are, how are they defined? First of all, they are defined as, like, let's say this is the line, this is kind of like the electric field that we have shown somewhere in the space. So how is it defined? Technically it is defined as it is the curve tangent to which at one single point, like this, tangent to it at one single point is going to give you the direction of electric field at that point. This is how we define it, and this is how it looks like. So it could be anything like this, and then you can find like what is the direction of electric field at this point. It will be tangential here like that. So whatever be the direction. So point number one, can they cross each other? Well, this is the first feature. They can never intersect each other. Why? Because if they will be intersecting like this, so there will be two directions of electric field at one point, because there will be two different tangents to two different curves at the same point, which means that electric field is having two different directions, which is of course not possible. So we have to say that they will never be intersecting each other, no doubt about it. Now after that, they are parallel to equipotential surfaces. Well, Of course not, because equipotential surface is supposed to be something like this, that it is always having 90-degree angle with the field lines. Everywhere it will be 90 degrees, everywhere. I know the diagram, it does not look like that, but it is 90 degrees. You can take the example of a simple spherical field line, kind of wavefront kind of a thing like this. And these are the equipotential surfaces. So you can see equipotential surface is always 90 degree to the field lines. So even B option is wrong. See, they are directed from negative to positive charges. Well, this is absolutely wrong. Why? I have given you one definition for what is the electric field line. There is another definition for electric field line. What is that? Let's say I have placed a very small positive charge here. So electric field lines, they are also defined as the path traveled by a very small positive charge when it is placed in the electric field. So the path traced by it will be the electric field line. So this is a positive charge, and of course this is also positive. So that is why we say that they are always directing away from the positive source charge, because the field line is the path of the positive charge that it will be following. Of course it will be going away from the positive charge and it will be going towards the negative charge. So we can just assume that yes, electric field lines, they are moving from positive charges to negative charges. They are originating from positive charges. They're always going into the negative charge. This is how we define it. That is why. So C is also wrong, but D is absolutely correct. Show the field strength by their density. Now what is this? Their relative closeness of the electric field lines, like this point here and this point here. If I compare point number 1 and point number 2, of course at point number 1 all the field lines are very near to each other, which symbolizes bigger strength for the electric field, and for 2 the strength is lesser. Now this is known as that the relative closeness of electric field lines depict the strength, and that is why D is absolutely correct for this answer. Okay dear students, this is it. Thanks for watching. This is Professor Varun. Keep watching. All the best. Okay dear student, let's see what is there in this question. What is the unit of resistivity in the fundamental SI units? Okay, so this is quite tricky. So I told you that whenever you are going to for the topic D1, D2, D3, D4 and the topic B5, be very careful about the units, because you might be getting this kind of a question and it will be very hard for you to find the unit for something which is electric in nature in the fundamental units. So that's quite tricky, but let's see. Let me show you how tricky it is. Now you want to find the resistivity in the fundamental units. So first of all, what are the fundamental units, because that topic is not in your syllabus. So there are 7 fundamental units. So let me give you the list of all those 7. So starting is kgs, and then meter the length, then second time, and for the temperature is Kelvin, for the light it is candela, for amount of substance it is mole, the quantity is known as amount of substance, it is mole, candela, Kelvin, and the 7th one is amperes for the current. Yeah, so these are the 7 fundamental units. So we have to convert the unit of resistivity into these fundamental units. Now what is the unit of resistivity? You must be remembering it is ohm meter, or you can even derive that from resistivity from this formula. Resistance is equal to resistivity into L by A. Now this ohm has to be broken down couple of times. Let's see. So ohm is resistance. How many formulas do we know? Like only one formula, V is equal to IR. So it means that ohm is equal to V divided by I. What is the unit? Volt divided by the ampere. Okay, no problem. Let us have it. So ampere is the fundamental unit, so no problem. But volt is not in this list, so I have to think about the volt again. Now what is volt? Volt is kind of like potential. The unit is volt. This is written as the potential energy divided by charge, isn't it? This is coming straight away from the topic D2 HL. So PE divided by Q. Now potential energy, the unit is joule, and for charge it is coulomb. Now both of them are not in our list of fundamental units, so we have to break both of them down. Now what about the joule? We have to think of another formula. Now we can say work is equal to F into S. Yes, the work is having a unit joule. Force will be Newton, displacement will be meter. So joule is equal to Newton meter, but Newton is again the composite unit. So let me break down that here. Now F is equal to m into a is another formula that I'm using. Newton is equal to mass into acceleration, kg meter per second square, multiply by meter, it becomes meter square. So joule can be expressed in fundamental units in this manner. So that will be substituted here. So it will be kg meter square divided by second square divided by coulomb. Now coulomb is again not in our list here, so what can we do? But I know that I is equal to delta q by delta t. From there we will find the coulomb. So from here I can say that the delta q is current into time. It can be written as ampere second. So this will be ampere second. Now this is potential, so I would be substituting in the potential. So the resistance ohm, oh my god, so for ohm it will be
family need.
second cube. I am making this second and second, and there is another ampere here, it becomes ampere square. So this is ohm. Now this ohm is later multiplied by meter, so this is again multiplied by meter. So for the resistivity it is kg meter cube second minus 3 ampere minus 2. So it is kg meter cube second minus 3 ampere minus 2. Oh my god, this is how we do it. So you keep on opening the brackets and brackets and brackets. So first of all it was ohm. Ohm has to be broken down into volt per ampere. Then volt will be broken down into joule per charge. Then it will be broken down into Newton. Newton will be broken down into the fundamental SI units. So this is how we do it. If there is any problem, please do mention that in the comment section. Okay, dear students, all the best. So C is the correct answer for this question. Bye. Okay, dear student, let's see what is there in this question now. A cell of an EMF 17 volt and the internal resistance R is connected to a two 10 ohm external resistors as shown in the diagram. There is a current of 1.5 amperes in one of the external resistors. What is the value of the internal resistance R? Now this is November 2024 exam that we are doing, and this was I believe the last exam from the old syllabus. So in old syllabus there were two topics, like number one is the Kirchhoff's law and another is the terminal potential difference. So Kirchhoff's law is clearly removed from our new syllabus, so we can get rid of that, and I will not be teaching you the same thing with the help of Kirchhoff's law now. But the terminal potential difference is in a bit of I would say a gray zone kind of thing. So it is clearly mentioned that the terminal potential difference is no longer in your syllabus, but there are some questions which you cannot be solving without the help of terminal potential difference. And also this topic is not omitted from any of the book. So all the books and different authors, they are still teaching the concept of terminal potential difference. That is why this topic is bit gray zone. So even if you are in the new syllabus, this question is very important for you. So listen to me. Now, so it is given this is 10 ohm, this is also 10 ohm, and one of the 10 ohm is getting a current of 1.5 amperes. Now, whatever happens to the battery here, the EMF is E, the internal resistance is R. If this 10 ohm and this 10 ohm, they are in parallel with each other, they will be having the same potential difference across both of them. And because they are having the same resistance, they are having the same potential difference, they will be having the same current which is passing through it. So even this will be having 1.5 amperes. So what is the potential difference here? V is equal to IR. So the current is 1.5 and the resistance is 10. So it becomes 15 volt. It means that the voltage across this is 15 volt. Similarly, the voltage across this is also 15 volt, and by the way, all these three things, they are in parallel with each other. So we can even say, we can jump to this conclusion that the potential difference across the battery will also be 15 volt. Now, how is the terminal potential difference defined? Terminal potential difference is defined like this. Like, this is the battery, this is the resistor, internal resistance R, this is EMF E, this point is A, this point is B. It says that the potential difference across A and B, it means VA minus VB, is known as terminal potential difference, and the formula for that is E minus IR if current is withdrawn from the battery. Now, if you say that current is not withdrawn, it is going into the battery, it is charging the battery, then there is another formula. For charging, it becomes E plus IR in the case of charging, and this is in the case of withdrawing the current. I hope that is clear now. So if you want to have some lectures on it, all the lectures for the topic B5 are available on YouTube channel, but you got to become the member on the YouTube channel to access those videos. Okay, so this is terminal potential difference. Now here, this is E, this is R. So yes, the current is withdrawn from the battery. So battery is losing its current. There is no problem, no doubt about it. So terminal potential difference is E minus IR, and the terminal potential difference will be equal to 15 volt, as we have already seen. So it is 15 is equal to E is 17 volt is the EMF which is given, minus I into R. Now what is the current? So 1.5 ampere is going in one current, resistor 1.5 in another. So total current is 3, and this is R. This is how we do it. So 3R is equal to 17 minus 15, which becomes 2. So R value is 2 by 3. So this is the internal resistance. This is how we do this question. Let us see if that option is available. Yes, C is the correct option for this question, and this is how we do this question. So I'm repeating the thing again, that there is the concept of terminal potential difference, which was removed by IB in the new syllabus guideline, but still it is in the gray zone. So I will not advise you to skip that topic. This is the topic, you have to remember it. Just keep it in somewhere in your mind. There are two formulas. One, when the current is moving away from the battery, so it will be E minus IR, and the other will be E plus IR. Okay, dear students, all the best. Bye. Okay, dear student, let's see what is there in this question now. P and Q are two parallel wires perpendicular to the page that carry the currents of equal magnitude in opposite directions. So this dot means that current is coming out of the screen, and the cross at Q, this means that current is going into the screen. Okay, so these two, they have the equal magnitude and they are perpendicular to the screen. The current in P is out of the page, and R is the fixed point equidistant from P and Q. So R is a fixed point equidistant. This is the distance that we're talking about. The distance from both of the wires is the same. What is the direction of magnetic field produced at R? So first of all, dear students, here in our syllabus we don't find the magnitude of the magnetic field because of the current carrying wire at a certain position. So that is not there, of course, so it doesn't matter what is the distance and all. But the only thing is that because they are placed equidistant from the point R, and they have the same amount of current in them, so we can just assume that they have the same magnetic field at this point. So both of the wires are producing same magnitude magnetic field at the point R. The only thing is direction, and as you all know that I am using I only use this right hand palm rule for finding the direction. Let us go for that now. So let's apply the right hand palm rule. Please be very careful. This is the right hand palm rule that I use, and it's very effective. So try to learn it. This is the right hand palm rule. I have created another video also that is also available. Just write right hand palm rule by Professor Varun and you will find the video. So there I'm discussing all the three types of right hand palm rule. So it's very important. So for P, the current is outside, so my thumb should be out like this. So thumb should be pointing towards me, because at point P the current is coming out of the screen. So this, and R is to the right hand side, so my finger should be pointing right hand side. So my palm is up. It means that my palm is pointing in upward direction, so I can say this is the magnetic field produced by P. So that will be the direction of magnetic field by P. Now what about Q? The current is inside and the point is at the top, so it will be this. It means that the magnetic field produced by Q at R will be having this direction. So this is B and this is B. Both of them have the same magnitude. Now if both of them have the same magnitude, of course we would be having the Pythagoras result here to find the vector summation of both of them. So this will be our final answer. As per the direction of the magnetic field is concerned, it will be A. What about the magnitude? They're not asking it, but we can even find the magnitude. When two forces or two branches or something, they have the same magnitude, the resultant of that, which is the diagonal of the square, it can be found very easily with the help of Pythagoras theorem. This always come out to be B root 2. So this magnitude comes out to be B root 2, by the way, but that is not the objective of the question. So your answer for this question will be A anyways. So this is how we do this question. Dear students, I'm using right hand palm rule instead of the Fleming's left hand root and right rule, because Fleming's rule is quite confusing, but right hand palm rule becomes very, very handy. So my humble advice to you is to use that right hand palm rule, and the video is also there. I would be tagging that video just after the screen. You can go and watch that video also. Okay dear students, all the best. Thanks for watching the video. Please continue watching other videos. All the best. Bye. Okay dear students, let's see what is there in this question. An aircraft of mass capital M turns in a horizontal circle. The net force on the aircraft is capital F. The second aircraft makes a horizontal turn with double the radius at the same speed. The mass of the aircraft is 1.5. What is the net force on the second aircraft? So this question is specifically referring to the use of centripetal force, because of which the aircraft is actually making a turn. So the centripetal force in the case 1, that is this F here. So I'm just writing it to be F here. So that will be given by mv square by r. So what is the mass? Mass is m. Velocity can be assumed as v, and the radius is assumed as r. Now in the second case, you can just call it F dash. The mass becomes 1.5 times. Velocity remains the same because it is moving at the same speed, and the radius is double, so it is 2r. So the only factor that we are multiplying extra to mvr is 3 by 2, but by this it will become 3 by 4 mv square by r. So need not to do anything, like I can just tell you that you have to substitute this here or not. You can do that. So if you want to find f dash in the terms of f, of course we have to substitute this value. F dash is equal to 3 by 4 times f. But otherwise also, whenever we are doing these ratio questions, always think from this point of view, like what is the extra thing that you have got in this equation. So the extra thing that you got was 3 by 4. So that so the answer will be B, that is 3 by 4 into f, because every other thing will be just substituted in the terms of f. That's it. So for this question number 18, the answer will be B for this. Okay dear students, this is how we do this question. This is Professor Varun. Thanks for watching. All the best. Bye. Okay dear student, let's see what is there in this question. An unstable nuclide has too many protons. What is the most likely decay of the nuclide? So this question is from a November 2023 question paper, which was the previous syllabus, and at that time there was a topic named 7.3 in which we were learning about each and every particle in the particle physics. And so the reaction that I'm going to write now, it was on fingertips of the old syllabus students, but for the new syllabus students it might be a shocker. Yes, listen to this. So there is a reaction, and in which the proton is breaking itself down into neutron, or it is converting itself into neutron. To conserve the charge, because the proton is positively charged, it will be giving rise to a positron, or you can call it beta plus. A positron, because here it is positive, here it is positive, and whenever there is a positron coming, there is a neutrino which is created. A neutrino does not have mass and it does not even have a charge. So it is written like this. Now, these are the subatomic particles. I know the new syllabus students don't know anything about this thing, but this was the part of topic 7.3 in the previous syllabus. It was so good a chapter, I would say. I loved this topic, and IB has removed this topic. So it's very unfortunate, but still I can say that this kind of a question is in a gray zone for the new students also, because this question that they have asked, that might be asked in the new syllabus also, because we are still doing that that graph of like the number of protons and number of neutrons, isn't it? So the graph goes something like that. If you remember, this is number of protons and this is number of neutrons, like that. And so this is the stability curve. So that is still in our syllabus, so to the best of my memory, I would say. So we can say that even like this question is not like, we can't say that it will never come back again. So that might be coming. So you need to just remember this philosophy here, that if a proton is converted, like it is having too many protons, so to make it stable, it has to break down the proton. So I will say that a beta plus will be generated, okay, or the positron will be generated. There is a vice versa reaction also, like the neutron is converted into a proton. Now at that time, to conserve the charge, because earlier there was no charge, so even now the total charge should be 0, it will be giving rise to an electron or the beta minus, and whenever there is beta minus, there is antineutrino. So this reaction is also a very important reaction for us. So my humble advice for the new syllabus student is to remember these two reactions. I believe that IB will not be asking you question on neutrino or antineutrino, but they will be asking questions on beta plus and beta minus. So these two reactions are in gray zone. We have to remember them. And so the answer for this question will be C. This is how we do this question. Okay, dear students, thanks for watching. This is Professor Varun. Keep watching. Going for the next question now. All the best. Bye. Okay, dear student, let's see what is there in this question. The 4 energy states of an atom are shown. Okay, so E1, E2, E3 and E4, they are shown here. What is the lowest frequency of radiation that can be absorbed by the atom? So you have to find like what will be the lowest frequency that can be absorbed by the atom. Okay. So first of all, we are talking about the energy absorption. It means that if the energy is absorbed, the electron will be jumping into higher energy state. So it will be going up, like it will be either going from E1 to E2, E2 to E3, but not the E3 to E2. That is not happening. So it will be 3 to 4, but 4 to 3 is not allowed, because we're talking about absorbed. And the lowest frequency, simple and straightforward concept. The concept is that energy is given by the product of Planck's constant and the frequency. You want to talk about the lowest frequency, it means you're talking about the lowest energy. So lowest energy, we need to find the lowest gap. So lowest gap is E4 and E3. This is the lowest gap. And we want to talk about the electrons going from the lower to the higher, because it is absorbing energy. So I can just say that it will be moving something like this. Like this. So it is going from E3 to E4. So what will be the change in energy? And this change in energy is equal to H, and this frequency will be F. So change in energy, final state is E4. So it should be E4 minus E3 is equal to H into F. And so E4 minus E3 divided by H, and D will be the correct answer. Accordingly, you can clearly see E4 minus E3 is equal to HF. So the frequency minimum will be E4 minus E3 divided by H. I just went for final minus initial, and you can clearly see that they have even created the option of C, which is E3 minus E4, and this is E4 minus E3. So from the magnitude wise, both of them will give you the same answer. But C, it will be negative energy, and energy has to be given out by the atom. And in the option D, it will be absorbing energy. So option D will be the correct answer. It is E4 minus E3 divided by H. Okay, dear students, so this is how we do this question. I hope everything is clear. If there will be any doubt, please ask me in the comment section. Okay, dear students, thanks for watching. All the best. Bye. Okay, dear student, let's see what is there in this question. The surface of the planet absorbs an intensity 400 watt per meter square. Okay, let me point out this is question number 25 directly, because the other questions from 21 to 24, they are not in your syllabus, so I'm not covering them. They have been removed. 25. The surface of the planet absorbs an intensity of 400 and reflects 100. So let's say this is the planet. So some energy is falling on it, and it absorbs the intensity of 400 watt per meter square and reflects the energy of 100 watt per meter square. The surface of the planet is at equilibrium at a constant temperature. The surface of the planet is at equilibrium at a constant temperature, because that is the condition of the equilibrium, that the total heat which is absorbed by Earth will be given out by Earth. Otherwise, the temperature of the Earth will increase. So they have just given you the condition in the second statement. What is the albedo of the planet's surface and the radiated intensity? So of course the total energy that is coming will be 500 watt per meter square according to this. 400 is absorbed and 100 is reflected. That is clearly given here, that 100 is reflected. Reflection is the albedo. So it's 100 divided by 500. Be very careful. So albedo will be 100 divided by 500, and it becomes 1 by 5, that is 0.2. That is the albedo of the planet. Now that is clear. So albedo is defined as the amount of energy reflected divided by the total amount of energy which is incident on Earth, and that is 500. It is 100 by 500. The answer becomes 0.2. So that is this. Now radiated intensity. Okay, now you want to find what is the radiated intensity. So of course all the 400 that is absorbed by Earth, it has to go out somehow. So Earth will be radiating this much of energy at some other particular time. Like let's say Earth is absorbing energy in the day and emitting energy in the night. So the surface where the night is there, let's say, at that time it is emitting energy from that part. So we can say that the energy balance is maintained. So of course the total amount of energy which was absorbed has to be given out. So the radiated amount of energy will be 400. Now the other option is 300, which is clearly not the case. So there is no doubt that our answer will be B. But there might be another doubt for the students, why the radiated intensity is not taken as 500 instead of 400. So my dear students, listen to this. Like if we talk about radiation, or let's say emission, the emitted energy or radiated energy, these two words, always remember these terms, this keyword, they always belong, they do not include reflection in their calculation. They are concerned with the energy which is emitted by Earth, as if the energy was its own energy. Like we have absorbed the energy some other time, and after a certain period of time Earth is started emitting the energy. It means like now Earth is emitting this energy as if this energy was Earth's energy from starting. So it is Earth's energy which is emitted. But if I talk about the reflection part here, of course this is not Earth's energy, because it was not absorbed ever. Like the energy is coming and going back. So it's kind of a reflection. So it is sun's energy hitting the surface and going out. So it is still sun's energy. But once the energy is absorbed by Earth, it becomes Earth's energy. So this 400 is Earth's energy. Now this is emitted based on the temperature of Earth. So this is what I want to say. The Stephen formula. What was that formula? Like the power is equal to E sigma AT raised to power 4. This formula I'm telling. So 400 will be used, and the temperature of the Earth's surface will be used. So this energy is radiated by Earth, and that is why the answer will be 4. It will not be 500. Okay, dear students, this is Professor Varun. Thanks for watching. Keep watching other videos. All the best. Bye. Okay, dear students, let's see what is there in this question. An iceberg oscillates up and down in the sea with simple harmonic motion. At time t is equal to 0, the iceberg is at the lowest point of its motion. So it's kind of an extreme position, we can say. At this instant, its displacement is negative x naught relative to the equilibrium sea level. The angular frequency of the iceberg is omega. What is the velocity of iceberg at the time t? Okay, so this question belongs specifically to HL topic, isn't it? Okay, so it is at the other extreme. So first of all, we have to create this equation. The equation for the displacement will be x is equal to negative x naught. Because it is starting from the extreme, it will be cos omega t. Why? Because it is starting from the lowest point. So the cos omega t graph is like this, but the negative cos omega t graph will be like this. And so it is starting at the negative already. It is said here it is starting at negative, so it will be this graph. That is why I'm taking negative cos omega t. So this becomes the function for the displacement. Okay, now if this is the displacement, we have to find the velocity. So you must be good with calculus, otherwise you won't be able to do this. Although I think this is covered in the part of maths AAHL calculus, you should be able to differentiate it. Okay, so x is equal to, like, we want to find velocity, that will be dx divided by dt. So minus x naught will come just like that. Cos omega t, when differentiated, it will become negative sine omega t. Negative and negative gets cancelled out. Omega will come out because of the chain rule. This will be our solution. So B will be the correct answer. I don't think that you could be able to do anything other than this. Like, you have to go for the calculus, because other than this, I don't think of any other method there. Or you can do one thing. You can just imagine that the velocity function will be sine. So this option is wrong, this option is wrong, and then you can just substitute the values. Like, let's say at t is equal to 0, the velocity should be positive. So t is equal to 0. Sorry, it is at the extreme position. No, yeah, it will be very difficult to imagine these kind of things. So I think this is the only method that I can suggest. Okay, dear students, if there is anything else that you want to say, you can message that in the comment section. Okay, dear students, all the best. Thanks for watching. Bye. Okay, dear student, let's see what is there in this question now. The light of wavelength lambda is incident on a slit of width b and forms a diffraction pattern. The central maxima has a width of theta radians. The central maxima has a width of theta radians. The wavelength of light is now changed to 2 by 3 lambda and the slit width is changed to b by 6. What is the angle between the first diffraction minima and the point of maximum intensity? Okay, a bit confusing question, and the statement given is very tricky. Let me tell you how and why. So first of all, it is the wavelength is lambda and the slit width is b and diffraction is taking place. No surprises there. The central maximum has a width of theta radian. Now this is the first tricky sentence. So what happens is, like, the diffraction is taking place. So this is what is, like, the diffraction pattern will be looking like. Yeah. So let's say this was a central point. So this is the width. This is the total width. So this sentence, the central maxima has a width of theta. They're talking about this complete theta. Quite tricky. Many of the students would have done this thing wrong. And the value of theta, it is lambda by b in the upward direction and lambda by b in the downward direction. So total angle theta that they talk about is actually twice of lambda by b. Now that might be the case that students might have taken it theta is equal to lambda by b, because that is how we remember. So that is why I say, like, this is the tricky statement here. The wavelength of the light is now changed to this. Now the wavelength is different. The slit width is different. The angle between the first minima and the maxima. So in the second case, he is not referring to this theta. Instead, he is referring to only this theta. That's the tricky part, isn't it? Another trick that they are trying to play here. I'm just calling this at theta dash. So theta dash value, according to us, it will be lambda by b, isn't it? Like it should be lambda by b. Like lambda will be the new wavelength. You can call it lambda dash and b dash. And there will not be any 2 here because we are only concerned with the upper part now, not the lower part. Because it is written that you want to go for the first minimum, which is this point, and the maximum point, which is this point. So you want only to find the angle theta dash. So here theta is twice of lambda by b, and here it is this. So what is lambda dash? Lambda dash is 2 by 3 lambda, and it will be divided by b dash, which is b by 6. So b, and this is 6, so 3 2s are. So it is literally becoming 4 times lambda by b. So you can see here it is 2 times lambda by b, here it is 4 times lambda by b. So if you want to find the value of theta dash in terms of theta, it will be theta dash is equal to 2 theta. Like, of course we know that theta here is this angle and theta dash is this angle, but this is how we relate it. Theta dash is equal to 2 theta. So C will be the correct answer for this question, and I would be rating this question as quite difficult, I would say, and quite tricky. There will be very less number of students, those who would be able to do this question. Otherwise there is a lot of confusion in this. So be very careful. And for the new syllabus, this is the topic C3. Yeah. Okay then, dear students, all the best. Thanks for watching. Bye. Okay, dear student, let's see what is there in this question. Monochromatic light of wavelength lambda is incident normally on a diffraction grating of slit spacing 9 lambda by 2. What is the total number of maxima that can be produced using this arrangement? Okay, dear students, so this question is from diffraction grating, and it is still in our syllabus. Like the resolution part of the diffraction grating is not in our syllabus anymore, but this is. So we would be doing this question. So a couple of things when you are doing this kind of a question. This is a bit confusing, I understand. Point number 1 that you have to understand is that whenever you are using diffraction grating, it is the formulas for interference which are more useful rather than the diffraction formulas. So diffraction grating is using interference formula. And what will be the formula now? So, and when you want to find the total number of maxima and all, so you just want to find the extent at which like the arrangement is going on. Like what I mean to say is, like for the diffraction, you know, like it for the interference it will be somewhat like this. So you are literally concerned with this spread, like here, this theta. So this theta, it will be sine theta is equal to n lambda by d. Sine theta is equal to n lambda by d. And n is the value, lambda is lambda. Now d value is 9 lambda by 2, so 2 can go to the numerator. This and this gets cancelled out, so you are getting a number which is 2 by 9 into n. Now that is the sine theta. What have I found here? So I'm talking about the first maxima, the second maxima, like that. Like let's say this was the arrangement, and the interference pattern modulated by diffraction, it goes something like this: 2 3 4 5, like this. Let's say we're just assuming. So this is first maxima, this is second maxima, this is third maxima. So here it is n is equal to 2, n is equal to 1, here n is equal to 0, n is equal to 3, like that. So here we have found this theta. So this theta is having this, and n is an integer value. So theta, sine theta should be less than or equal to 1. It means that n has to be less than or equal to 9 by 2, which becomes 4.5. So n is an integer, so n will be equal to 4. It means that n is equal to 4 is also there. So 1, 2, 3, 4. So 4 maximas will be housed inside the diffraction pattern. So this is interference pattern modulated with diffraction. How many total number of maximas can be seen now? So 4 on this side, 4 on the other side, 1, 2, 3, 4. 4 on the other side, and 1 the central maxima for which n is equal to 0. So 4 on that side, 4 on this side, 8, and 1 central, that is 9. So your answer here will be 9. This question cannot be done in any other method. You have to use this exact method. This kind of questions, they were important for the old syllabus. They are important for the new syllabus also. So this is a very important information. So all the lectures are already uploaded on the YouTube channel, by the way. If you become the member, you can access those videos, and you have to watch those lectures to understand each and everything in details. Okay, dear students, thanks for watching. This is Professor Varun. All the best. Bye. Okay, dear student, let's see what is there in this question now. X shows the position of the spectral line in the emission spectrum of helium from a stationary source in a laboratory on Earth. The emission spectrum of helium from a star moving towards the Earth is also observed. The speed of the star relative to the Earth is 0.1 c. What is the observed position of same spectral line in the emission spectrum of helium from the star? So first of all, this question is very important for the New Year syllabus. Why? Because number one, it talks about the spectral lines, which is covered in the topic E1 for the new syllabus, and it does talk about the Doppler effect and the radiations. Even that is covered in the topic C5. And on it, it is talking about stars and when the star is moving towards the Earth and all. So we are also talking about the astrophysics subject, which is covered in the topic E5 now. So this question exclusively becomes very important for New Year syllabus. Okay, now, so this is the radiation that you are actually getting when the experiment is conducted in the laboratory. So this is the radiation that you're getting. So there will be some certain frequency which will be coming out of that star, that helium gas, isn't it? So that particular frequency is this. So we can say that this is the original wavelength, like the original wavelength, because its wavelength on the y-axis, that is y. So whatever be, it be the original frequency, original wavelength. Now, so first of all, we have to apply the concept of Doppler effect here. So Doppler effect goes something like this, like delta L by L is equal to V by C. Now this happens when you're talking about electromagnetic radiation, which, like for example, you're talking about stars and light is coming from that star to Earth. So this is about electromagnetic waves. So we can say this is Doppler effect in electromagnetic waves, Doppler effect in light. So that formula we are going to use. So this is delta lambda by lambda is equal to V by C. Well, of course, it is equal to delta F by F also. So it can be written in either way. So it can be taken as delta F by F also, but we want to talk only about the wavelength. So this V is now 0.1 into C divided by C. So it gives you 0.1 value. So the change in wavelength divided by original wavelength, and when you multiply it by 100, you get the percentage change. So it pertains to 10%. It means that the wavelength is undergoing 10% of the change. Now whether it is increasing or whether it is decreasing, now that we are able to find only through because of our understanding rather than the mathematics part of it. So as a matter of fact, when the star is moving towards Earth, like the distance between the two astronomical bodies or the source and the observer is reducing, then the frequency will be increasing. As a thumb rule, you can say if the bodies are moving closer to each other, the frequency is increasing. It means wavelength is decreasing, because V is equal to F lambda, frequency, and V is equal to F lambda. So velocity is not changed. So it is an electromagnetic wave which is traveling with the speed of light, and you can't change it. So it is speed of light with which it is changing. So more is the frequency, lesser will be the wavelength. It means wavelength is decreasing. By how much percent? It is decreasing by 10%. So this is nearly 590, you can say, and the 10% of that will be 59. So that will be subtracted from it. So it will be nearly 531 something, isn't it? 41. Okay, so it should be nearly this. So B will be the correct answer. You need not to find the exact value there, so that's okay. So the answer for this question will be B. Couple of points that we noted here. Number one, we used the Doppler effect for electromagnetic wave, Doppler effect for light, which is delta lambda by lambda is equal to V by C. Accordingly, we multiplied by 100 and we thought and we found that the change in wavelength should be 10%. So now the second question is it going to increase by 10%? Or is it going to decrease by 10%? Because if it was supposed to increase, C could be the correct answer. But it will be decreasing. Why? Because the bodies are coming closer. The star is coming closer to Earth. It means that the frequency is increasing, means wavelength is decreasing. Hence, B will be the correct answer. Okay, dear students, this is Professor Varun. I believe it is pretty clear now. So keep watching the videos. All the best. Bye. Okay, dear student, let's see what is there in this question. The diagram shows the gravitational equipotential surfaces around two identical masses. So point to be noted, there are two identical masses and like the mass of these two bodies is the same. Now there are 3-4 points that they have shown, and these are gravitational equipotential surfaces, so the potential remains the same on one single line. So the potential at this point is equal to potential at this point, and it is equal to the potential at Z. But for Y it is different, for X it is different, for W it could be different. The greatest external work is done when the test mass is moved from what point to what point. So you're talking about the work done. So the work done can be written as the product of the mass which you are moving from one point to another and the change in potential between the 2 points. So that this will be the work done. So you want this work done to be greatest, and of course the mass of the body cannot be changed. So it will be the same, that is m. So you just want to maximize the change in the potential. So it's pretty clear here. Now what are we going to see? Like for A it is x to y. So I can say that when both of these masses are actually identical, so the potential here Vx will be equal to Vy, because the masses are the same, the source masses, and they are like the point x and the point y, they are equidistant from the masses. So we can just look at it and say that the potential will be same. So if it is moving from x to y, the potential is the same, the work done will be 0. My dear students, in this, do not apply the formula F into S. You can't apply this. There are students, those who do that, and they say that, sir, the distance between x and y is very large, and so if it will be moving like that, there will be a lot of work that has to be done. No, we are not going to consider this philosophy here. So this is a very different kind of a scenario. In this, we are just going for this thing. So you have to find what is the potential difference between the 2 points. You plug that value here and you find the work done. So x to y, so Vx to Vy, that will be 0. W to y, now W is some point in between. So if I create an equipotential surface for W, it might be looking somewhat like this. So I can say that W is here. So clearly the potential of W is lesser than Z and more than Y, kind of like, okay. So W to Y, it is going from W to Y. So that's not the maximum thing. So B is also wrong. Now if it is going from Y to Z, now that could be the answer, because Y would be having kind of the minimum potential and Z will be having the maximum potential because it is farther away. So as you keep on moving farther away, the potential keeps on increasing. So Y is minimum potential, which is equal to X, and Z is the maximum potential. So of course it should be Y to Z. So it will become Z minus Y. So C is absolutely correct. Now what about the D option, W to Z? So W to Z is again not that very big gap. So the gap is lesser. So D is also wrong. So for this, C will be the correct answer, and this is the reasoning for this question. Okay, dear students, so thanks for watching. This is Professor Varun. Keep watching other videos. All the best. Bye. Okay, dear students, let's see what is there in this question now. The graph shows the variation of gravitational potential V with the distance r from the center of the planet of a radius capital R. Okay, so as I have already told you in my lecture classes that the gravitational potential, as a thumb rule, it is always negative. It can never have a positive value. So all the values will be negative and they will start from the surface of the planet and they will move like this because there is the hyperbolic variation there. Yeah. So a mass m is placed at r is equal to 3r. So this is the point where a mass m is placed on that point. What quantity when multiplied by m gives the gravitational potential energy of m due to the planet? Okay, So what energy it will be, like we have to find the potential energy due to the planet. So clearly we know that the formula for the potential energy is, or I would say that the formula for the potential is given as potential energy divided by the mass m. As I told you, it is per unit mass, isn't it? Like mass was supposed to be 1 kgs, or you can say it is the total potential energy of the system per unit mass of the test mass, isn't it? So Pe by m. So you want to find the potential energy, so mass has to be multiplied by the potential at that point. So if you talk about this 3r here, so it is like this. So this is the potential which is at that point 3r. So the potential energy will be m times v. So you find v here and you multiply with the m, so you would be finding the potential energy. I think that gives our answer. But let's go for the options now. So point number A is the gradient of the tangent at line r. Now gradient has no meaning here. Like if you're finding the gradient, E is given by negative dv by dr. So if you find the gradient at this 3r point, let's say at this point you are finding the gradient, you like this, so you would be finding the electric field, sorry, not the electric field, I'm really sorry, gravitational field strength or gravitational field intensity, although they are corresponding things in the two topics. Okay, so you would be finding the gravitational field intensity, or you can say gravitational acceleration at that point. So that will be because of the gradient, but we don't want it. We want to find the potential energy, sorry. Area under the curve r to 3r doesn't make any sense. That will give you, what is the area? It will be v into r. So v into r, I don't think it means anything. Okay, gravitational potential at 3r, that is correct. Difference in gravitational potential value. Now the difference between the gravitational potential value will be the change in potential energy if the body is going from 3r to r or r to 3r. So you have to find, like, so this D will be giving you change in potential energy, but you don't want the change in potential energy. You want the potential energy in absolute terms. So C will be the correct answer. This is how we do this question. This is the explanation, dear students. Okay, dear students, thanks for watching the video. All the best. Bye. Okay, dear students, let's see what is there in this question. The escape speed of the planet X is given as v. The planet Y has twice the density and half the radius of the planet X. What is the speed required to escape the gravitational field of planet Y? Okay, so on the surface looks easy, but let's see. The escape speed, it is given by 2gm by capital R square root. And this is the formula which is given in the data booklet also. So 2gm by capital R. Capital M is the mass of the planet, capital R is the radius of the planet. So this is what is happening in the case of planet X. Now in the case of planet Y, they are talking about the density now. Now IB is very fond of this thing, and this is not the first time they're asking this question. There are other questions also. You can just search my Google, my YouTube channel, and you will find so many questions which are related with escape speed and density. So it's not a surprise. Now mass of the planet can be found by volume multiplied by density. So volume of the sphere is 4 pi 3 pi r cube, again given in the data booklet, and this will be multiplied by density. So I can substitute this value here. So I'm creating another journal formula for myself, and this is 4 by 3 pi r cube into density divided by r. This r and this r gets cancelled out. It will be r square. Yeah, I can just write r square here. Okay, so this r is completely cut off there. So 2g 4 by 3 pi is a constant value. You are left only with rho and r. Okay, so it is 8 by 3 g into pi like this. Let us just create this formula and keep it like that. Now, so what are the changes? The density for y is double. Density is double, so you would be multiplying twice here, and half the radius. So radius will be divided by 2. It will become 1 by 4. So 4 goes to the denominator. Every other thing is just copied like this. So this 2 and 2 is going to cancel it out. Square root is always there. So we can just substitute this value here. So I can see that only 2 in the denominator is extra. All other things, they are the same. So it will become Vx, like this is Vx, divided by root 2. Well, I hope you are able to substitute this in an easy manner. Like you can do whatever you want. You just try to find the common thing. So the common thing is this. So this will be substituted as Vx and you would be left with the square root 2. So this is your answer. But here, as we can see, that you can't find this answer readily. Like that is not available here. But they are very, like they have given these options in a very tricky manner. So you can multiply root 2 above in the numerator and root 2 in the denominator. So it will become root 2 Vx divided by 2. And that is the option C. So this is how we can do this question. This is how we do it. Well, this process is known as rationalization in the terms of mathematics. But I believe that you people don't use rationalization even in mathematics, like AAHL, I believe. So if you know it, this process is called rationalization. Whenever there is a square root in the denominator, you multiply numerator and the denominator with the same value so that it becomes a bit more presentable, I would say. Yeah, this is how we do it. So the answer for this question is C. Okay students, thanks for watching the video. All the best.
Playlist भी जरूरी है क्योंकि अपन उत्थों दी बंद करना है actually. वो बंद आपे नहीं ना होना.
Okay, dear student, let's see what is there in this question. A circular coil of wire is in a region of uniform magnetic field directed out of the page. Okay, so the magnetic field is shown here in the diagram. We can clearly see, and whenever it is shown with the dot and having a circle on it, it means that the magnetic field is coming out of the page. So it is coming out of your laptop towards you. The area of the coil in the region varies with the time t. Okay, now in this case, area is a variable. So this ring is becoming bigger in the radius and smaller in the radius, like that. So there is some change in the area which is taking place. What is the variation of induced current with respect to time? Okay, so we would be talking about in the terms of flux here. So the magnetic flux is given by B into A into cos theta, which can be written as omega t if the coil is rotating, but the coil is not rotating at all. So this theta is having a constant value. Theta is the angle between the magnetic field vector and the area vector. Area vector, be very careful students, area vector is perpendicular to area. So if this is the coil, this is the area vector is perpendicular to it. It means that in this case, area vector is also coming towards me or coming towards you, you can say, like that, out of the laptop screen. And the magnetic field is also coming out of the laptop screen. Both of them are parallel, the angle is 0, so cos 0 is 1. So it becomes B into A. That is the flux. Now, we want to find the EMF. So EMF will be when we are going to differentiate this thing. So the magnetic field is not changing, but the area is changing. So it will become B into dA by dt. See, I know the calculus is not in your syllabus for physics, but this much of calculus I think you should be good with. Why? Because it is covered in the syllabus of your mathematics there, like maths AAHL is covering differentiation. So this differentiation should not be difficult. So EMF will be given by dA by dt. Now dA by dt is the slope of this graph. Like A is on the y-axis, T is on the x-axis, so you have to find the slope. So clearly the slope is negative, 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 and immediately it becomes 0. So the negative slope is becoming more negative, it is increasing, and then it becomes 0, and then immediately it becomes positive and it becomes maximum, and then it starts reducing again, but it is always positive. So now dA by dt, we are going to comment on dA by dt. What is going to happen? Okay, I can just assume this doesn't look like sine theta or cos theta, by the way, but guessing from the options here, because this is clearly the sinusoidal variation, so you won't be getting the sinusoidal variation if this variation which is shown for area is not sinusoidal. So I can assume that this is sinusoidal. It's kind of cos theta variation. So when you differentiate the cos, you would be getting negative sign. So clearly the graph which is showing you the negative sign, that should be the answer, and that is done in the option B. and D is wrong, C is wrong. So option B is only one such option in which looks like negative sine theta, isn't it? So this is how we do it. So initially it is reducing, but it is increasing its value. After that it becomes constant, but it is still negative, and then it starts reducing the value, it becomes 0, and after that it again goes to the positive axis, and this is how we do it. So the answer for this question will be B. Let me repeat this question once again. Like, what I'm saying is that the graph here, which is given for area, it's clearly, like, they have not written anywhere that it is cosine variation or sinusoidal variation. Even I was confused earlier when I saw this diagram, because this is clearly not sinusoidal. But if it is not sinusoidal, you will not be having the answers which look like this. Which look like this. This is not possible. Okay, so we assume that this is positive cos theta. When we differentiate it, we get negative sine theta, and so B will be the correct answer. I hope you understand. If there is any problem, please do mention that in comment section. I will upload another video for the same question. Yeah. Okay, dear students, thanks for watching this video. This is Professor Varun. All the best. Bye. Okay, dear student, let's see what is there in this question. An alternating current generator. Okay, dear student, let's see what is there in this question. The radius of a sphere is capital R. The absolute uncertainty in R is delta R. What is the fractional uncertainty in the volume of the sphere? So it's a very typical question from the topic of propagation of errors in error and measurements. Although, like, this topic is not given and specifically in our new syllabus, by the way, but of course there are details. Of course we have to do this topic, and this is one of a very important topic for the paper 1B. So let me tell you how are we going to do these kind of questions. Let me tell you how do we approach it. So first of all, we are going to concentrate on a formula which relates the volume